Hello, everyone, and I welcome you all to our session on making agents remember using Amazon Bedrock AgentCore memory. So before we begin our session, I'm Mani Kanuja. I'm Principal Generative AI Specialist Solution Architect at AWS. Very excited to be here with you today morning. And before we begin, can I have a quick show of hands for people who are aware of the memory concept in the agentic AI world? Okay, awesome. So we have many folks who are aware of, and we also have few of the folks who will be hearing about the agent memory for the first time, and what role does it play. And today I also have with me Jay, who's our product manager, and Imran, who's from Experian, sharing the stage with us. He's the senior VP, head of engineering from Experian, and he'll be sharing the journey and how Experian has been using AgentCore memory for building their applications. So very excited to be here, and I hope we all have had your coffee so that you're all awake. Is that true? Okay, awesome. Let's get started then. So the main thing about the memory when it comes to agentic AI applications is providing the right context to the agent at the right time. And that's what we see the agent applications without memory lack. And by the end of this presentation, I promise that you will understand and also see a good demo on how it can make the difference when you are building the agentic AI applications. So let's talk about the context first. What goes into the context of an agent? And what really this agent is? So when I think about agent, it's literally a model that has access to some of the tools. It can take actions on your behalf based on the tools that you provide. Now, those tools could be some data APIs, real-time APIs that you want the agent to give access to, or it can be access to your knowledge store where you have your organization data. Or it can be instructions, and system prompt is super important because system prompt is what makes the agent understand what it's supposed to do, right? So there's so many things that goes into the context of an agent. And that's where we have seen that memory is often overlooked. But imagine you are in a party, you have been talking to few people, and suddenly, after the conversation is over, and you're like, oh, what's your name? Right? So we don't want our agents to be in that situation, especially when they are interacting with your users. You also want to give a good user experience or customer experience in addition to providing relevant and accurate responses. And that's where memory plays a big role, and it literally is bridging this gap. So let's take an example. So obviously, like for this presentation, we had to build our presentation, right, the slide deck. And then when we were discussing, we were like, OK, why not take this example and share how you can build slide decks? So we built a slide deck agent that can do a lot of things. So I started with a very basic agent with no memory. It was good. It was able to do the work. If I provide a big prompt, I give all the instructions, it's able to generate the deck. I have to give some tools, such as I love Python, so I provided some tools like Python PPTX and all of those, and it did a good job, no doubt about that. But then I noticed every time I have to mention, oh, for technical presentations, use this style. I'm in AI, and responsible AI is close to my heart. So in all of my presentations, I want some angle about how people use this AI responsibly, right? So those are my preferences, which I wanted the agent to remember. But with this basic agent, I always have to provide these instructions over and over again. So how do I overcome that? That's where I created another agent with memory. Now, this agent could understand my preferences over time. When I was building a lot of slide decks, it learned my preferences, and then after a while, I just say, oh, for tech presentation, this is a tech presentation on this topic, and it will just do the job. And not just that, because I know when we are talking about it, we make it sound very simple. So that's where we will show you this demo up and running. So stay tuned. It will be at the end, so you have to stay for that. And also, I want to make sure that you understand the fact that how memory bridges this gap when you are interacting with the agent. So when the user is interacting with the agent, there is conversation. There is a lot of context that agents need to remember. So we have to make sure that that context we are providing to the agent so that they give response in an accurate, reliable way, relevant response, and also give good customer experience. You don't just want your agents to remember stuff. You also want them to be smart. And they can only be smart if they're able to retain that knowledge, if they have the full context of your application or the job that you are asking the agent to accomplish. You want the user preferences, or maybe the facts, or maybe the summary of the previous sessions to be remembered and retained by this agent, or maybe the agent should be able to call those things. So those are the things which are very critical. For example, you had a long conversation with the agent, and then you come back, and what you want to do is basically resume from that conversation. That's a very common use case. But imagine if you're storing the entire conversation history, it will go so big, right? So you might want to summarize it, and maybe when your user comes back, the agent can say, you know what, last time when we interacted, you talked about these topics. Do you want to continue with these topics, or you want to start a new one? So those are the things that you want your agent to remember, right? It would be so cool. So that's where you want your agent not just to remember, but be smart about it, be able to recall those things. And that's where we are going to show you how would you do that. Now let's talk about this demo sneak peek that I talked about, right? So the first thing when you're building an agentic application, you need the interface. Your UI should be attractive, should be nice, but at the same time, you need some kind of a framework to build your agent. So in our application, I'm going to show you two agents. One, the agent without memory. Second, the agent with memory. And you will see the difference. We are going to give the same prompt to both of these agents, and I'm using Strands framework to build these agents. Then, of course, the main layer, we are talking about memory. We want agents to remember, right? So then for this demo, I have the memory hooks. So why memory hooks, and what are these hooks, right? So within these frameworks, when we are using to build agents, there are two ways. One, you can use memory as a tool, or you can use memory as a hook. So why we use memory as a hook? If we want to make sure that agent calls the memory at a specific time in their life cycle. For example, on every message added, I want my agent to add it to the short-term memory. And then there is a long-term memory, which agent needs to retain the key specific facts, right? Maybe I can use that as a tool, because whenever the agent needs it, it can retrieve from the long-term memory, right? So that's how you need the memory hooks, and sometimes memory as a tool, depending upon your application. Memory hooks is a more deterministic way of agent making sure that every message added goes to the short-term memory. Then when you are using these frameworks, there is a session manager that you might need. And this will become more clear when we'll go through our presentation. Then there is a configuration, like what gets extracted from the short-term memory and goes into the long-term memory. So you should have control over that, right? So in my demo, I'm using the memory config, where you can literally override the prompts, figure out what gets extracted, and we are using user preferences for this demo. And all of this will become clear when we'll do a deeper dive on how AgentCore memory will help you out. And the last but not the least, I want to mention what the services that we are using. So I'm using Amazon Bedrock, Anthropic Claude 4.5, Sonnet 4.5 model. I'm using AgentCore memory. And of course, security is super important. So with IAM permissions and integration with memory makes sure of that. It makes sure that I'm only giving the permissions that the agent needs to do its job, nothing more than that. This helps me in reducing my blast radius. So one of the key principles of security, the principle of least privilege. So that's what this does. So now you have looked and you have got some idea about what this demo is going to look like. But now imagine you have to build all of this on your own, the whole memory system. I'm not even talking about building agent and deploying it, just the memory system. Imagine you have to do all of this on your own. What would you need? So short-term conversations or the short-term memory should have everything as is, like some raw messages, some storage. And you should be able to give, let's say, last K turns to your agent. So that will maintain your conversation history. So there's the short-term memory, right? Short-term memory is literally like raw messages. I should be able to retain, I should be able to call. So you need some kind of like a database or a key value system which can store these messages. Now, long-term memory is that the agent should remember, for example, if we are talking about user preferences, across multiple sessions. So I need a different type of a data store over there. Why? Because based on the query, the agent should be able to semantically retrieve the information. When I say semantically, I mean based on the meaning of the question, it should be able to extract the right information. So I need maybe a vector store for that, right? Now, these two storage systems, I have to make sure that I'm managing. There is a memory refresh all the time. My data is refreshed. I have automatic pipeline. Whenever there is a duplicate user preference, it's consolidating, it's updating. It's not really adding new preferences without consolidation. Because imagine, if I tell you that I'm a vegetarian and I'm a non-vegetarian, what will you serve me when I'm with you? Nothing, because you are confused. But because I was a vegetarian earlier and now I'm a non-vegetarian, it makes sense for me to order non-vegetarian food or the agent to give me recommendations of the non-vegetarian food, for example, right? But if I give both those things, the agent will get confused. Oh, what do I need to do now, right? So the consolidation logic becomes very important. So you have to do that on your own. And you have to do all of this in a very secure way. And not just that, imagine something happens while your user is interacting with the application and you need to troubleshoot or you need to debug. You need to build and integrate observability into your system. So all of this becomes really, really a lot of work and heavy lifting. So that's where we have Amazon Bedrock AgentCore to help you out so that you can focus on doing what you do best, is building applications for your customers. And we take away all that heavy lifting from you. And you should be able to quickly integrate memory into your agentic applications. Now to go deeper into this, now I'll invite Jay, who is the product manager for AgentCore Memory, and the best person to talk about it.
Thanks, Mani. I think in that case, with the meal, I'd probably go vegetarian, just to be safe. All right, so we built AgentCore Memory, as Mani mentioned, to ensure that your agents have the right context at the right time. It's a fully managed service that addresses many of the traditional challenges associated with agentic memory. Let's look at how it works. So we're going to do another thought exercise here. I want you to think about a conversation that you've had in the last week or so. You probably remember that conversation pretty well, maybe even word for word. Now, why don't you think about a conversation you had about a year ago? If you went to reInvent last year, think about a conversation at reInvent or a presentation at reInvent. If not, maybe last Thanksgiving or last Christmas. Now, for that conversation, for that interaction, you probably don't remember it super well. Your brain probably remembers the most important details and generally what happened. And you might have used that information to inform future conversations or future interactions. That's how your brain works, and that's how we designed AgentCore memory as well. It all starts with your memory resource, That's this blue and slightly pink box surrounding your short-term memory and long-term memory here. Within the memory resource, which you set up in your AWS account, we have short-term memory. That's your raw interaction history, that word for word that you remember more recently. And that persists for from 7 days to up to a year based on your configuration settings. And then we also have long-term memory. And your long-term memory are that important information, those key insights that persist throughout. And your agent can retrieve both short-term memory and long-term memory in order to complete the job at hand. So let's start by looking at how short-term memory works. In short-term memory, your agent interactions are captured and sent to the memory resource in the form of events. Events contain an actor ID, so who this is, or maybe who it is combined with what the agent is, and a session ID, which is generally your specific interaction. And the actor ID and the session ID can be used in conjunction with the events, with that raw information, for easy context tracking. Events can contain your conversation history, they can contain metadata, and they can also contain blob payloads, so images or audio, things like that. This is most useful for hydrating your agent with the recent conversation history and the recent interaction history. This is sort of the baseline at this point, and this is that example Mani gave of having the conversation and then someone comes back and says, "Who are you?" No one wants their agent to be a goldfish, is what we say. And short-term memory is really good with that. It has a few other uses as well. And for that, I'd like to talk about a topic that is near and dear to me, unsuccessful so far, and that topic is convincing my family to get a golden retriever puppy. So I've been unsuccessful so far, and I'm thinking about a new approach. And that new approach is using the PowerPoint builder agent to create a PowerPoint convincing my family to get the puppy. So I'm going to tell it to include a bunch of cute pictures. I'm going to tell it to include some of the pros of getting a puppy, getting a dog in general, which include that it teaches responsibility, that statistically people who have dogs are shown to be happier. And I'm also going to ask the agent to do a bit of a financial analysis to address some of my family's concerns that maybe costs are an issue. So I've put in a lot of effort here, gone back and forth with the agent, and the most annoying thing that can happen, the screen goes blank. Let's say I quit by mistake. Now, it can be really painful to get back to that exact point. It can be a lot of effort. With AgentCore memory, conversation history can be stored, and also interaction state can be stored. And what that means is that you can go back to the exact spot where you are, and hopefully, I'll keep you posted, next year at reInvent, we'll have a puppy. AgentCore memory supports a few other advanced features for event organization with short-term memory, one of which is branching. Branching is useful for going back and editing messages or editing events. And it's also useful for concurrent event streams. So what that means is, let's say I put in some effort for this presentation, and I wanted to get the agent to go off and build me one presentation on getting a golden retriever puppy, one presentation on getting a Siberian husky puppy, and maybe one presentation on getting a German shepherd puppy, though I doubt that last one. AgentCore can do that with branching and maintain logical separation. So that's short-term memory, and now we're going to look at long-term memory. With long-term memory, your raw interactions from short-term memory are automatically transformed into structured and persistent insights. Unlike short-term memory, where the interactions are full interactions, your full conversation history is captured, with long-term memory, we only pull key insights that you're going to need over time. It's a multi-step process to capture these interactions and write them to long-term memory. And as you may have guessed, we're using large language models for this. You may also be wondering how we know what information to pull into long-term memory. And the answer to that is by choosing a memory strategy. We have 3 built-in strategies: summary, user preferences, and semantic. And it's very simple to add those. You go into the AWS console or add them via API or programmatically. You pick the strategy you want, you add it, and information automatically starts flowing from short-term memory into long-term memory. So really easy. We really like that. The strategies themselves are pretty self-explanatory. Summary condenses down your interaction, condenses down your conversation, and saves that. User preferences captures the user's preferences. So for me, for that interaction we talked about, it might be the user prefers golden retrievers and Siberian huskies to German shepherds. And then semantic captures facts about the interaction. So that one might be user has a family and family wants a dog, hopefully. You may also want a little more control over what you send into long-term memory. And that's what those bottom 2 strategies are for. So with the override strategy, you can choose which large language models to use and what prompts to use to send information into long-term memory. Self-managed gives you complete control over the extraction process. So what we do with that is we deliver the events to an S3 bucket and notify you of those. And you can pick up those events, bring them through any sort of processing you want, and write them to long-term memory as memory records via our dedicated APIs. All of these strategies can be, memory records created from these strategies can be retrieved semantically, so based on a query search. And memory and strategies can be combined as well. And if you think about it, it makes a lot of sense to want to summarize your interactions and also capture facts about it. So if you're creating an agent, summary and semantic might be the way to start. And then as you want more control over time, think about looking at override or self-managed. So let's put all of this together. We're going to start on the left side here. As we remember, interactions, conversations are captured and sent to the agent as short-term memory, as events. Depending on the strategies you've configured, those events are sent into long-term memory as memory records. Both short-term memory and long-term memory, both events and memory records can be retrieved by the agent to complete whatever task it is that the agent's completing. You may have also noticed we now have Agent 2 and Agent 3 up here. Multiple agents can write to and read from a single memory resource, so That's an option you can make, and we can support multi-agent use cases. Or we can support just one. Yeah, so that's AgentCore Memory. It's a fully managed service with built-in observability and enterprise-grade security features. And now I'm going to pass things over to my friend Imran at Experian to talk a bit about his organization's experience with agentic memory.
Thanks, Jay. I'm Imran Shah. I'm here today from Experian to talk about what you have heard from Mani and Jay in terms of putting this into perspective with the likes of an organization and enterprise scale. I'm here to talk about Experian journey of how we have moved from a short-term memory to a unified memory architecture, and especially using AgentCore memory to simplify our direction within Experian. As all of you can experience today, the whole AI across enterprise is a rapid evolution. On a daily basis, it is changing. And that is how Experian was thinking before AgentCore in terms of short-term memory, as Mani said. We talk about something we introduce with our name, and I forget who you were. That's short-term memory. So we have actually pivoted our roadmap with this whole AgentCore long-term memory architecture, and we have adopted that in the pilot mode within Experian, and I'm going to take you through that journey today. A little bit about Experian. As you know, the credit bureau, all across the globe, we have credit bureaus. We are an innovative global data and technology business. And our main aim is to work towards the financial health for all. We have around 1.5 billion plus consumers across the globe. And we serve both small, medium, large, 201 million plus businesses across the globe, across the geography. From our richness perspective, we serve 25,000 employees across 32 countries, and from a domains-wise, you can name it, as you can see, cable to credit, not only credit, but also data, solutions, automotive, healthcare. And we are delivering this whole with a 99.9% accuracy of data across multiple domains. Now let's talk about Experian AgentCore journey. As you heard from Mani and Jay, we started our journey with a short-term, very product-specific memory implementations. And very quickly, we realized that's not the way to go. And we changed our unified approach to more conversational context and moving towards long-term. What AgentCore has also brought us is rethinking our roadmaps in terms of how Amazon Bedrock, AgentCore memory, we are actually moving to more time to value, simpler journeys, and pivoting our roadmap towards that. And we'll talk in subsequent slides about how we are doing that in perspective. So, as you can see in this diagram, our current memory implementation is across products in two different ways. One is managed memory, where you have assistants which are using tools like OpenAI, providing thread-level memory. In the right-hand side, we also have custom memory implementations, which are some of the agents leveraging OSS open source frameworks, again, providing thread-level memory. In the contrast, as you can see, we have a managed and we have a custom. Both coexist, which creates a lot of user frustration and confusions across teams. So, from a short-term memory perspective, as you can see, it works, but it doesn't scale into the enterprise world. A very small company with even 500 employees or 200 customers, even in that regard, short-term memory has some limitations. Starting with the first one, which is more around continuity and persisting the long conversation histories. The second one is more around performance and cost, which is very important to all organizations at any scale levels. We also have cross-product recall issues, which leads to a lot of user frustration where no memory recall happens across the threads or products. And last but not the least is the compliance, and regulatory, where it is difficult to meet your regulatory or compliance needs where you have to go back 2 years and represent any retention requirements. It's very difficult to achieve that with the short-term memory. If we now move on to more context orchestration and how unified memory has changed our whole implementation and the roadmap with this, as you can see, there are 2 planes of context here. We have a authoritative context, which is more around knowledge bases, APIs, you have databases, the things which are kind of your knowledge ecosystems. And you have a conversational context which has short-term memory, it has long-term memory, and it also has the agent state. When you combine these 2 planes of context into a more context workflow, it becomes very impactful for an organization which can scale from an enterprise perspective. Your LLM reporting can be much more efficient, and your user personas can give you the user context which is required by a user. Before pre-AgentCore, our planned architecture for unified memory looked like this. Like any other build scenario, a classic build scenario where you have a conversational manager which stores and retrieves all your conversations. You also have a memory manager which stores and retrieves memory records, powered by a typical memory store or a vector DB store. And your ETL pipeline is kicking off periodically in order to feed this. So this model had a lot of, I would say, significant operational complexity due to managing multiple custom components. So this was pre-AgentCore. Now let's talk about what was after we have implemented AgentCore, long-term memory assumptions into our roadmap and into our architecture. As you can see, it is a lot more simplified, both in direction and also in terms of the architecture. With this, you have a fully managed conversational store, you have a fully managed conversational APIs, and you have 0 ATL overhead for your extraction of your memory. What it brings to the table for an enterprise-wide scale is faster time to value, improved operational efficiency, and a lot of increased functionality. In this scenario, our engineers focus on building agents and not worry about the infrastructure. So this is how we have simplified our direction, and we are still in the process of improving towards a better scale and a better roadmap for Experian. Our core design principles, which are underpinning all of this architecture you have seen, the current state and the 2 state, is leveraging these 4 pillars, evaluation and test frameworks, which actually continuously evaluate your memory extraction processes. We also focused on cross-agent memory interoperability so that we can enable agents to share memory across different agents, because then they can orchestrate with each other and give you a very informed opinion with the context in mind. We also have shorter targeted context windows with this, which keep it very purposeful and concise. And namespace-based isolation, which every enterprise would need in terms of achieving multi-tenants architecture where you can serve multiple tenants with the same master shared kind of architecture. So these are some of our core design principles which are not only met with this whole design, but also we keep this on a daily basis. Now, this is where a design for privacy, transparency, and control comes in. The whole memory governance service, which we have designed with this, it's a unified first way to manage long-term AI memory. What it allows is a user can selectively delete their own memories if they don't need it, and an administrator would be able to will have an ability to purge it on a periodic basis when it is required. So it gives the control in hands of a user and also in the hands of administration if they need to take some action in terms of purging. The whole approach actually enhances great user experience, trust, and more importantly, it ensures compliance for guidelines like GDPR or CCPA. And these are very important because at the heart of Experian, we believe in security, compliance, and user experience all together. So I think AgentCore memory architecture is bringing all that to life for us. It's solving multiple problems and also giving us a way to scale at an enterprise AI-wide. With that, I will also thank our partners who have helped us doing this implementation from Tiger Analytics and AWS team. And at this time, I'm more than happy to hand it over to Mani to take us through a very impactful demo. With that, thank you so much.
Okay, I'm back. Hard to get rid of. Okay, no worries. So now that you have understood about AgentCore memory, that Jay went deep into the constructs, the components, how it works, and especially, I would like to thank Imran on sharing how Experian has been using it in their products and how it was able to simplify their implementation and also scale. It is so important to make sure that your agents and your applications can scale. And when we are building AgentCore memory, we are taking that into mind because that's what our customers like yourself have been asking us, right? So with that, I know it's time for the demo, which I promised you right in the beginning. So are you all ready for the demo? Okay. So this is the demo that I built using AgentCore memory. So as promised, there are two agents, the basic agent, which has no memory, then the memory with the agent, and a comparison thing. And as you can see, I have some slides that I've already built out using this. So my agent now should remember my preferences. But let's see the basic agent first. You can see there is it doesn't have any memory. I can build some prompts, provided it's a full running application. And I have to provide the prompts. I have to mention that I like the blue theme. Or if I don't mention anything, it will just use the default. But when I go to the memory-enabled system agent, then as you can see, it can remember my styling. Like for technical presentations, I like the purple theme. I like the technical font. So because I've already built out presentations using this agent, it's able to capture it in the long-term memory. And also some real-world use cases that it should include in all of my presentations. And also it shows my obsession with AI. So it's capturing that the user likes to build the AI presentations. So it literally shows that I'm into it. And then you can literally create a smart presentation, and now I don't have to specify my preferences over and over again. But who am I to say that? Let's see it in action. So with this agent comparison thing, I'm going to give the exact same prompt to both of these agents at the same time. And as you can see, I'm not going to provide my preferences. Even this prefer and clean, let's remove that. Let's just make it simple. What type of presentation I want, the key components. So now this is behind the scenes what's happening. So you can see my prompt behind the scenes, it calling the basic agent first. It gave the whole prompt. And after this, now you will see that it is also calling the memory agent. Let's take a closer look. And the topic and stuff, so that it can search the long-term memory behind the scene and find the relevant preferences related to the content. But I also need preferences related to the styling. So then it's again making a call for my styling preferences and finding and searching and retrieving the right memory which might be relevant to build this presentation. And then it is applying those things, as you can see in the back end, to build my presentation. So it's all done. Now let's take a look into and get back to our UI. So there are two comparisons, and it's also giving a good understanding and a summary what these two agents have done based on the styling, based on the preferences. So with the basic one, it is using blue because that's the default theme that I have provided, but for the styling that it has applied to the memory agent is the purple theme. Yes, I'm obsessed with the purple color. So now let's take a look again at those preferences, because I want you to remember those, because when you see the actual slides, you are able to correlate. This purple theme, tech font, AI ethics, I'm obsessed with AI, it shows everything. So my agent knows me, right? That's the main idea behind it. So now let's take a look into the deck. Now you can see there is AI ethics deck added to it. Let's take a look at the basic one. Blue theme, as it's a default one because I never provided what I want, no styling preferences. It is still doing a really good job, as I explained to you earlier. It is giving the slide, the format, and everything. So now let's take a look at the memory agent. Look, my style, purple color, tech font. This is basically the font that you see while you do the coding in one of the IDEs, so I like that. So now you can see those concepts into the presentation. So it's not just about my style and the preferences, but even if you look closely at the content, you will realize that it has incorporated those things, the content that I prefer in my deck. Obviously, this is 25 slides. I couldn't go through all of them, but I've shown you some of those ideas. And if you are interested, this demo is actually in our GitHub repository. If you search AgentCore samples, GitHub, under memory, you will see this full demo code, and you can try and play it yourself. OK, so now that we have seen this demo, it is using AgentCore memory. I was able to integrate, based on the APIs, my existing agent. I started with the first basic agent, and then I integrated this with the memory. I literally called some of the APIs. It took me a few minutes to do that. But then there are a lot of other use cases as well. The example that I gave you is literally related to the content creation example. So you have this on the slide, right? But there are way more use cases than these 6 of them that I'm showing you on the slide deck, because obviously there is not much space and not much time to talk about all the use cases in this hour. So let's take an example of some of the other use cases that might be relevant to you. So a quick show of hands. Have you used Coding Assistant to build your code, like vibe coding? OK, I see a lot of them on the left side, center, and the right. So you are aware. OK. Have you noticed this? When you are using the Coding Assistant and you provide all the instructions, it generates the code. Then you run the code. There might be some issues, right? And then you give some additional instructions. And there is one instruction specifically that at least I give when I use the vibe coding thing, is make changes using minimal lines of code. Do not create any new files if they are not needed. Because agents usually, when you ask them to fix anything, they will create a bunch of test files. So that's like every time you have to type those instructions if your Coding Assistant doesn't have a memory. So have you noticed that one? Or is it just me? OK, I do see some nodding heads. Absolutely. So that's an indication to integrate your Coding Assistants with AgentCore memory. It will make your job easier. You don't have to type these instructions over and over again. And whenever you are making an edit, you are just saying, oh, edit this file. How cool will that be? So that's one use case on how you can build a really smart Coding Assistant which can literally remember your preferences, your style, Maybe you love coding in Python, so it should not generate code in Java, or it should not continuously ask you which language, for example, right? So personal to you, understanding your experience, giving you a better experience. And this is exactly what you want for your customers. So another example, let's talk about a customer support agent. Now, with the customer support agent, you would call the customer support for a specific issue, for example, talking about a refund, or maybe something else that you don't like the product, and you want a replacement, for example, or you just want to complain that it took so long for the product to arrive. So those are some of the queries on the customer support for an e-commerce thing, right? We all do online shopping, so I just thought, let's use that. Now, what you want is, you want this customer support to remember the past issues. Why? Because you want to understand your users better. Is this customer having the same issue over and over again? So what's going on? Maybe it's time that you might want to update something. Or maybe for the agent who's on the other side can quickly look and say, oh, you know what? This is how we fixed the issue in the past. Let's do the same thing again. So those information becomes, that type of information becomes critical to providing good experience to your customers who are on one side, and to your agent who's actually interacting with the customer and providing a better experience. So memory becomes important because that shows how much you care about your customers, because you are remembering their preferences. You are not just giving them the accurate and reliable help, but also remembering them. That's the thing that you want to give to your customers. So also, I want to make sure that next, whenever you're building an agentic application, think about not just the accuracy, relevancy, those are very important, absolute must things to have, but also think about your customer experience. Also think about how you can minimize these number of calls that the agent has to do, because that will save you the cost also, right? So providing the right context to the agent at the right time. You have AgentCore memory as one of the components that will help you without you having to do too much heavy lifting, because we are taking care of that on your behalf. So with that, there is a next step that I really want you to do. What we have presented today is actually the beginning. It's not the end of the presentation. It's literally the beginning. There is more to come, and more to be seen and heard at this reInvent. So I invite you to join the keynote by Dr. Swami, who will be talking about the new features that we'll be launching across our AgentCore line of products or services. And also, I want to invite you to build one of these use cases, connect with us, either on LinkedIn, or shoot us an email, or reach out to your account teams, and they can connect you with us. And I'm so excited to hear your stories and understand what you are building next. So with that, thank you so much for your time today, early morning, and I know it's difficult to get up, but you are here. So thank you, and thank you for that.